Okay, today I'm going to talk to you about extracting metals. We use metals all the time in everyday life, but in order to use the metal, we need to extract it first. Extraction just means getting it by itself. Now, there's a few metals that are so unreactive that they just find uncombined in the earth. So this is a reactivity series here, the most reactive metals at the top, the least reactive at the bottom. I've done carbon in capital letters because it's the only one on here which isn't a metal. So these ones at the bottom are so unreactive that we can just find them uncombined in the earth if we dig them up. This means that if I dug up gold, it would just literally be a chunk of gold rather than having to find it and take it out. I think in order to understand that, we need to know what an ore is. So basically, an ore is when a metal is found in the ground reacted with oxygen. So in a compound with oxygen. So an example is something called bauxite, which is aluminium ore. So it's Al2O3. So bauxite is something called an ore. In order to use aluminium, we have to extract it, which means we need to remove it from the oxygen. So there's two different ways of extraction that we need to know about. The first one, these ones I've kind of highlighted in green. We can extract these metals by using reduction using carbon. Now the reason why we can reduce these using carbon is because they are below carbon in the reactivity series. Anything above carbon we cannot use this method for. So how does it work? Let's imagine we have iron ore. So iron ore, also known as hematite, is iron oxide. Again, iron in a compound with oxygen. What we need to do is we need to heat it in a blast furnace with carbon. When we do this, we can see we have a displacement reaction happening. Because carbon is more reactive than iron, it's higher than it on the reactivity series, the carbon will replace the iron. This is called a displacement reaction. So the iron will be left all by itself. Remember, that's what we're trying to achieve. We're trying to extract the metal and get it all by itself so we can use it. So now I've got the iron, and also now I have the carbon combining with the oxygen, and the gas formed is going to be carbon dioxide. Now, like I said, this can't happen with all of the different metals or metal ores from the reactivity series. If I have a look, for example, at aluminium, bauxite, it's more reactive than carbon. So if I tried to do this, there would be no reaction at all. So for these metals, we need a different strategy. For these metals that are more reactive than carbon, we need to use electrolysis. Now electrolysis, think about the word electro means using electricity, and lysis means splitting or separating. So electrolysis just means separating using electricity. So let's have a quick look at how this works. So what I'm drawing right now is two different electrodes, a positive electrode and a negative electrode. The positive electrode is called the anode and the negative electrode is called the cathode. So what we need to do, the very first thing we need to do, let's say if I'm trying to extract aluminium from its ore, bauxite, first thing I need to do is melt the bauxite. Now this will require a really, really high temperature. So it's very expensive to get it to melt, to create enough energy and heat to melt bauxite. Now the ions that I'd have in solution are Al3 plus ions, so aluminium ions, and oxide ions as well. Now within electrolysis, remember opposites attract, so these positive aluminium ions are going to go to the cathode and these negative oxide ions are going to go to the anode. So what I'm just going to show real briefly is the reaction that's going to happen here, because at the anode we have our oxide ions are going to form oxygen, and we're going to actually lose some electrons here. And at the cathode, we start off with our aluminium ions, and they are going to be reduced. They're going to gain electrons to form aluminium. Now, I've gone through that bit really briefly. If you want to learn more about this, please watch the video about electrolysis. Now, the big problems associated with electrolysis is it's extremely expensive. The reason why it's expensive is we need to melt all of this, melt all of the bauxite first, so it requires loads and loads of energy, and there's a lot of electricity is required to be passed through the electrodes in order to cause the movement of these ions. So it's extremely expensive and uses lots of electricity. But if the metal is more reactive than carbon, we don't really have a choice because we can't extract it using reduction with carbon. So that's how we extract metals. The least reactive ones are uncombined elements. The ones that are less reactive but are in an ore, less reactive than carbon but are found in an ore, we can extract using reduction using carbon. And those metal ores that are more reactive than carbon, we have to use electrolysis. Thank you.